As we've seen, relational database management systems are very powerful tools for structuring our data. However, there's nothing magical about an RDBMS. Just like any other piece of software, there's nothing inherent within it that forces us to use it correctly. We could use MySQL, for instance, in exactly the same way as we use a filing cabinet, a card index, or a simple file structure. The process of normalization are a set of formal disciplines which allow us to make sure that our database systems get the most out of the relational database model. The best way to explain how the process of normalization works is to take a look at a very faulty database and then apply the so-called normal forms to this database and improve the database until it's fully normalized. I'm using the library database, but in a very crude and unscientifically formed format. If we take a look at the table definition here, there's only one table, the books table. That includes the title of the book, the name of the publisher, the number of pages, size field, which allows us to get an idea of the size of the book, and the year it was published, the name of the genre, and the author's name. Now, there are a lot of problems with this table and the way it's structured, but let's first of all take a look at those features of it that violate the maxims of the first normal form. To begin with, there's no primary key. We need a primary key for a table to meet the conditions of the first normal form. We need to therefore add a primary key, and we also have a problem with including the author name all in one field or one column. This is because when we come to run a search, for instance, and we want to search for Gibson, we will have a problem because we'll have to search on part of that column. This will be a very inefficient way of running any kind of search on that. So let's take a look at the first normal form version of this particular database. We still only have one table, but now, as you can see, we've created a primary key, and the primary key is on the title and the author surname. We've also split that author column into three columns: the author first name, the author initial, and the author surname. This respects the principle of atomicity, which is that each of the columns should be an atomic unit of data, that is, can't be broken down any further in the way that a full name such as William Gibson can be easily broken down into two names. There are still a lot of problems with the structure of this table. The first of which is that the primary key is not, although it looks like a fairly safe one, Neuromancer by Gibson, is not of itself a unique identifier that could not, under all possible circumstances, be duplicated. We would be better off using the ISBN, which is the unique number that is applied to every book that's published. So we can incorporate that. Another far more serious problem is that we include the names of the publishers with every book. We're also including the names of the genres with every book. We're including the names of the authors with every book. So, although we may have 5 or 6 books written by the same author, we're going to have to store that author's name 5 or 6 times. This allows us to store the author's name spelt in a slightly different way each time, forces us to waste space, and allows for the kind of errors caused by duplication of data. It also violates the principle that a table should store information about one logical entity.